unmute myself or अब okay, our objective is to develop the LCG, which is Linear Congruential Generator, to develop the random numbers one by one after the other. And the formula is xk plus 1 equals modulo of axk plus c to m. So I import numpy as np. This library contains the function mod function. So I take the typical values, okay, one test values. So I define m equals 32. Then I take x naught 31, a 21. So I say x naught equals 13, a equals 21, and c equals 1. Python is case sensitive, so one should choose the naming convention and variable writing in intelligent way. A21. So let's generate say 100 random numbers. So I call that one x, capital X, equals numpy zeros 100, 100 zero values, and d type I write here float. It is optional. If you do not provide it, it will identify it by its context. So x is 0, right? So all values have been set to 0. So by the way, this is the vector to store random numbers. Right. So first random number will be x0 equals x naught by m, right? So random number is normalized. First number 13 by 32. So this has become the first random number. Now this is the starting point. Now how do we generate the next random number? We have to multiply xk with the a, and then we will get the next plus c and compute the modulo. So I write here the expression for x new. I say x new, a new value will come from the mod function numpy mod a times x old value, right, plus c and modulo of m. That's it. So we have got a new value. Let's check the algorithm up to this point only. So x new. So I look for a new value of x. X new is this one, right? And the next step would be to repeat this one. So first random number was say 13. If we look for unnormalized value 13, the next has come 18. Now if I change this one to 18 and repeat this calculation, I will have another number, right? So we have to repeat this calculation by updating the values, and then we will do the storage, right? So I write here, do this value. So since first random number has been generated, so I say for I in range 1 to n, right? So I can say 1 to n. So a new value of x new has been generated. Since Python requires the indent, so I have introduced the indent here. This is the new value, right? A new value. But to store this new value, next step is to store the value. Store the new value. Normalize and store the new value, right? Normalize and store the new value. So how do we store? So in X vector, now this should be the ith value, or in order to make it exactly consistent with the algorithmic notation, I say it is xk, right? So xk value, or I can say here up to n minus 1. And now I can say it is xk plus 1 equals, xk plus 1 will be equal to x nu divided by m. So it is normalized and stored. It is normalized by n. And now the update of value, something that I did earlier by running the program and changing the value. So in order to update, I can say x old is now equal to x new, and repeat this set of calculations, right? So this is the update of the starting value. Update the starting value. So now program will run it and store it and normalize it by itself. And 100 for 100 values it will run. So xk plus 1 will, when it is n minus 1, it will change it to n, right? And that's it. So first number was generated just by normalizing it, and now 100 numbers will be generated. So now I run it. Okay, there I missed the colon sign, which is important in the for loop. So there are two steps: k in range, k in range, and k plus 1. N is not defined. Oh, pardon. So I want to run it 100 times. So basically I should write it 100 here, right? So instead of this 100 n, it will be more generic. So then it is fine. So all variables must be defined. So we have everything generated, but we have not seen the output. Let's see the output here. Our output was stored in the vector x. So let's write the vector x. So there are values. So let's see the starting value, 0.5625, and see the values. Can you see 0.6525 somewhere? This is the 0.6525 value, right? And after that, all the sequence is repeated, right? So let's check where the value is repeated, right? So the first value, because this algorithm is working with the first value. So I say if x, capital X, k plus 1, if xk plus 1 is equal to x of 0, the first value. If it is equal to the first value, yes, double equal is for the equal sign. Logical equal is with double equal. If it is equal to this one, then break the loop structure, right? It means stop. And this is the end of if statement, end of if statement. And this is the end of for, right? So now if I run this one, and now I say print the value of k. So at which value the value of the first number was repeated. So it says 31st value. Since it has numbered from 0 to 31, so it is the 32nd value which is repeated, and 32nd value is consistent with the selection of m, right? So similarly, if I say select this one equal to 64, so now the repeating cycle would be 64. Let's test it. Great test, right? So, but these 64 numbers are random. So this is the the simple implementation of the linear congruential random number generator, right? So the selection of M X naught A C, we have taken the simple set. So if you enhance it, then if you change it, you can see the working of this algorithm. So this is one of the fundamental algorithms for generating random number.